What if space and time are not fundamental but rendered from entanglement and interference? In holography, uncertainty causes the quantum field to oscillate as probability waves of phase and frequency. As those waves overlap, regions of extreme information density collapse into microscopic black holes called Kugelblitzes. Kugelblitz structures radiate through Hawking radiation across the holographic boundary. Hawking radiation acts like a universal read and write process, projecting and decohering quantum information simultaneously. Entangled particle pairs separate, with one particle moving inward, while its reflected partner remains projected outward. As the inward particle changes orientation, the reflected particle mirrors that motion across the horizon. That mirrored motion continuously etches quantum state vectors onto the holographic boundary itself. Like watching a movie inside a mirror, the horizon carries a living reflection of the deeper field. The holographic projection itself performs the decoherence process. Projection and observation become the same process within the holographic field. The horizon acts as both the universal projector and universal observer. It collapses the wave function while simultaneously projecting the hologram of reality itself. Each qubit receives a spinning directional arrow called a quantum state vector. The orientation of those arrows defines probability, velocity, motion, acceleration, and curvature. Quantum state vectors project onto the axes as measurable velocity and probability components. Those projections create an intensity map equivalent to the Born rule in quantum mechanics. Constructive overlap increases probability density, while destructive overlap reduces probability density. Curvature emerges from the changing orientations of entangled quantum state vectors. When those vectors connect tail to tip through entanglement strength, they literally draw space-time geometry. That geometry is also a computation performed by the decohered quantum field itself. Curvature and computation become the same underlying process within the holographic projection. The entire system behaves like a quantum computer built from entangled qubits. Stable standing wave interference patterns become atoms, orbitals, chemistry, stars, galaxies, and the periodic table itself. Orbitals form where coherent interference creates stable probability regions around repeating wave structures. The world we experience appears as four-dimensional space-time. 3 dimensions of space and 1 dimension of time emerge from holographic projection. The horizon behaves like a 2-dimensional informational boundary tiled with Planck-scale qubits. Just as a hologram projects higher dimensional structure, the horizon projects space-time itself. Prime frequencies create uneven informational spacing across the holographic horizon. That uneven spacing orients the directional arrow of the quantum state vector itself. Perfectly symmetrical frequencies rapidly decohere into diffuse background structure, appearing as dark energy. Semi-coherent structures persist as dark geodesic scaffolding curving galaxies without becoming luminous matter. Prime frequency structures resist decoherence most strongly and stabilize into luminous matter. Mass becomes a standing light clock repeating coherently through the holographic projection. As Sir Roger Penrose described, mass behaves like a clock defined by repeating quantum frequency. Riemann zeros represent resonant boundaries, organizing interference and projection geometry. Wave-particle duality emerges because quantum states evolve as overlapping probability waves before projection. Interaction across the horizon localizes the interference pattern into measurable outcomes. That is why the double-slit experiment produces interference until direct measurement collapses the pattern. Wave behavior and particle behavior emerge from the same holographic process. Your brain reads those interference patterns like a quantum QR code through neuronal microtubules. Tubulin dimers contain electric dipoles carrying spinning directional arrows across their probability fields. Those dipole interactions orient quantum state vectors across the tubulin dimers themselves. The tubulin dimers organize into cylindrical microtubules, rebuilding geodesic structure from entanglement. Orchestrated objective reduction collapse transforms those reconstructed geodesics into conscious experience itself. Sight, sound, taste, touch, emotion, distance, and perception emerge from that holographic rendering process. The universe is a holographic quantum computation, observing itself, projected across the horizon of your mind.